Welcome back to Mr. DuPage's classroom. This lesson is for my General Algebra 2 class. This is lesson 1.2, Introduction to the Parent Functions. In algebra, functions belong to certain families. Just like you belong to a family, you're kind of a copy of some sort with a few changes from your parents, right? The parent of each family is the simplest version of each family. The chart below shows these families. These are your parent functions. The first one is a constant. A constant would be of the equation f of x equals c, or just f of x or y just equals a number. The graphs can be a straight line, the domain is all real, and the range would be y equals whatever that number is. It intersects the y-axis at 0 and that number. The linear function, we've talked about linear functions in the past, they are straight lines. That is f of x is equal to mx plus b is really the equation. But as you can see, the parent function would be f of x is equal to x. The domain and range of that would be all real. That means it goes on forever in both directions. It intersects the y-axis at 0, 0. Your quadratic, we talked about in your last lesson, is x squared. That's the way it looks right there. The domain of that will be all real, and the range is y is greater than or equal to 0. That also intersects at 0, 0. In fact, all of these parent functions are going to intersect at 0, 0, other than our constants. Cubic is our x to the third. Its domain and range is all real because it goes on forever in right to left and up and down. And the square root function is the square root of x. Its domain is x is greater than 0 and y is greater than 0 because we cannot have a negative number in for x. All right, now that we got through that little table, you can always go back and take a look at that table anytime you feel like you need to. Let's continue down here. Stop. Get rid of when you said let's continue down here, say it again, and start over. All right, so let's continue down here. Yesterday we learned each function can be moved or transformed in various ways. The negative coefficient, what did we learn about what happens if there's a negative in front of our parent function yesterday? Well, that means it's going to reflect over the x-axis. How about if the coefficient a is greater than 1? That means that there is a whole number in front of our x. Then we are going to stretch by a factor of whatever our coefficient or the number in front of our x is. How about if the coefficient of a is less than 1? That's if I had a fraction in front of our x. Well, then we are going to shrink by a factor of whatever that fraction is in front of our x. How about adding and subtracting inside the parentheses? Well, inside the parentheses, we're going to have a translation, and we're going to go opposite the sign. So if we add inside of the parentheses, or our sign is positive, then we're going to translate left. If we subtract, we're going to translate right. Okay? It's all stuff we learned yesterday. How about adding and subtracting outside the parentheses? Well, again, that's going to be a translation. It's going to be a translation. This one's going to be up or down, and we would follow our sign. Okay? So if I add, and it's outside the translation, then I would translate up. If I subtract, I would translate down. Okay? Those are all things, just a review of what we talked about yesterday. So let's go ahead and try to identify parent functions and then describe the transformation or transformations that took place. So in the first one, I have a straight line. What is that called? Well, that would be a linear parent function. I can just write linear there. As we're looking at the equation, I do not see any parentheses. So if there are no parentheses there, I can put them around the x, which means that I'm going to subtract outside of the parentheses. If it's outside the parentheses, I move up and down, and I follow my sign. So this would translate down 3. Okay, let's look at number 2. I do have parentheses here, and this one is a squared. We have a squared function. As you can see, this would be one of our graphs that looks like the U, which we know is a quadratic. Okay. We have parentheses here, so if we have parentheses and we're adding or subtracting inside the parentheses, we know we're going to move right or left, and we're going to go opposite that sign. As you can see, the original parent function would start there. We move to the right 7, so we translate right 7. Okay. Looking at number 3, I have x to the third. What is that known as? Well, that is a cubic. Another way to say x to the third is x cubed. That should help you remember. Again, I do not have any parentheses, so I can go ahead and add them just around my x, which means that I'm going to be adding outside of the parenthesis. We just talked about what happens when we add or subtract outside the parenthesis. In this case, I'm going to follow my sign, which is positive. So if I have a positive sign, I'm going to translate up 2. Number 4, I have the square root sign. Again, we treat everything under the square root like it would be something that's inside the parentheses. But there's another thing that's happening here. How I want to read this is from left to right. So the first thing that I run into is this negative that's out front of everything. If there's a negative out in front of everything, it's going to reflect over the x-axis. I forgot to say what my parent function is here, but this one's one of the easier ones because that's a square root sign, so my parent function is known as a square root. Okay? What's the next thing I run into? Well, I run into this positive 2 underneath the parentheses, or underneath the square root, I'm sorry. Underneath the square root is the same thing as being inside the parentheses, so we know it's left or right movement, and we're going to go opposite the sign. So in this case, I would translate left 2. Okay? Let's move on to number 5. Most of that stuff up there should not be overly difficult for most of you. Number 5, we need to graph the data from this set of ordered pairs, describe the parent function, and the transformations that best approximates the data set. Well, the first thing I want to talk about is in a ordered pair, it is always x first, y second. And as you can see in our table, it tells us what our x's are and our y's are. So the first number I need to, or the first ordered pair that I need to graph is -2. So I'd go 1, 2 from 0. Then I'd go up 12. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. Make sure you get rid of those other little points there. We don't want those in there. The next ordered pair would be -1, 3. So if I go to -1, then up to 3, 1, 2, 3. There we are. Then 0, 0. Then I have +1, 3 and +2, 12. As you can see, when we connect all these points, kind of looks like a U, right? Kind of looks like a U. So what it's telling us to do is we need to describe the parent function and the transformation that best approximates the data set. What that means is our best guess as to what happened to our parent function. In this case, we know it is a U-shaped graph. A U-shaped graph would tell us that it is a quadratic function. So it's a quadratic. It looks a little skinny to me. It looks just a little skinny to me. So in this case, I think it's going to be a stretch. It's going to be a stretch. But what did it stretch by a factor of? Well, if we think about the original parent function, we would still use 0, 1, and 2 in these locations, right here. Well, 0 squared is going to be 0. 1 squared would actually be 1, and 2 squared would be 4. So what did we multiply by to go from 1 to 3 and 4 to 12? Well, we multiplied by 3, so this is a stretch by a factor of 3. Okay? The next thing it tells us to do is to go ahead and graph the data from the table in number 6. Describe the parent function and transformation that best approximates the data. I want you to go ahead and do that yourself. Go ahead and pause the video, try it out, come back and see how you did, and we'll work from there. Go ahead and stop. 0, -4, 1, 2, 3, 4. Whoa. -4, 0, 1, 2, 3, 4. 3, 1, 0, 2, 5, 1, 2, 3, 4, 5, 3, 6, 7, 8, 9, 10, 11, 12, 4. 3, 2, 1, and go. As you can see, now that you've restarted the video, I went ahead and plotted those points for us. If I go ahead and connect all those points, what I have there is just half of a sideways U, right? Well, half of a sideways U is only one thing, and that would be a square root. This is a square root function. Well, let's think about a square root function like we did before. If I have -4 under a square root, I don't think that's going to work very well. In fact, I know it won't because we cannot take the square root of a negative number. So the best way to figure out how this worked out is we just look at, if I had the square root of 0, it would be 0, right? That would be my parent function. The square root of 1 would be 1. The square root of 2 is not going to come out to a whole number. The square root of 3 is not going to come out to a whole number. But the square root of 4 would come out to 2. So 1 or 2, 3, 4, 2. The square root of 5 is not a whole number. 6, 7, 8, but 9 would be, and that would come out to 3. 5, 6, 7, 8, 9. That comes up to 3. And let's go ahead and look at what happened here. The first thing I want to see is how far from my parent function points are the other is the new function. Well, it looks like it has moved to the left 1, 2, 3, and 4. I wonder if that happened with the next one. 1, 2, 3, and 4. 1, 2, 3, and 4. 1, 2, 3, and 4. So it does not look like I stretched this or shrunk it by any factor. It looks like it just moved to the left 4. So I would call this a translation, or translate left 4 is what happened to this one. Okay, let's go back. Let's go down to the end here in 7, 8, 9. Need to extend the page. The first one, we need to identify the parent function and then tell the transformations that took place. Well, because this is raised to the second power, we should know that is a quadratic. Now I'm going to move from left to right to look at the different transformations. The first thing that I see is this number 3. That 3 is being multiplied by what's inside the parenthesis. If we're multiplying what's inside the parenthesis, we have called that a stretch by a factor of 3. Now the next thing I run into is this -2. This -2 that is inside the parentheses. Again, anything that is inside the parentheses is going to be a left or right movement. So it'll be a translation, right? We know that it's a translation. It would be a left or right movement. But do we follow the sign or go opposite the sign? Well, we're going to go opposite the sign. So since it's negative, I'm going to go ahead and say that it went right 2. That's all the rest of the movements that I see in number 7. Why don't you go ahead and try number 8 and number 9 on your own? So just go ahead and pause the video, give it a shot, come on back when you're done, and we'll see how you did. 3, 2, 1, and go. Well, number 8, I see the first thing is this 3. It's x is raised to the third, so this is going to be a cubic function. What about number 9? It's again raised to the second, so that is a quadratic. Hopefully you can name your parent functions at this point. Once we have named our parent function, we are going to look for the first movement coming from the left going to the right, just like you're reading a book. The first thing that I would look at and see is this 1/5. That's multiplying by my x. Anytime I multiply by my x, I'm either stretching or shrinking. This is less than 1, so I would shrink by a factor of 1/5. Number 9. Well, actually, number 8, are we done? Yes, we are, because it doesn't add by anything. It doesn't subtract by anything. There's no more parentheses. So there is nothing left to transform our parent function. Number 9, we already said it's quadratic, but reading from left to right, the first thing I see is this negative sign in front of my 4. What does that negative sign do to my graph? Well, it is going to go ahead and reflect the graph over the x-axis. Yes, you do have to write all these things out in order to tell me exactly what you're talking about. The next thing that I run into is this 4. Well, again, the 4 is multiplying by my x, just like on number 7, just like on number 8. That means I'm either going to have a stretch or a shrink. In this case, since that is greater than 1, I would have a stretch by a factor of 4. Since there's nothing else that adds or subtracts, then we know we are good. The big things we just talked about today is how to recognize what each parent function is. There is that table on the front that would help you really understand that very well. We also talked about a negative coefficient will reflect over the x-axis. A coefficient of a being greater than 1 will stretch it. That is the same thing as number 9 and number 7 there. A coefficient that is less than 1 would shrink our parent function. That's the same thing as what we did on number 8. If we add or subtract inside of parentheses, then it will be a translation left or right, and we will not follow our sign. And then also, if we add or subtract outside of the parentheses, then it's going to translate up or down, and we will follow our sign in that situation. Well, thank you very much for watching my video. That is the end of our lesson, and have a great day.